Appreciate it. Thanks for the introduction. Super excited to be here. I'm Colonel Alex Goldberg, go by Storky. I am the Texas lead for strategic engagement for the Defense Innovation Unit. And I'm proud to have with us today Colonel Diller, the Director of AFWERX, and Colonel Bartolome, two very seasoned experts in digital engineering and having a profound impact within the DoD. At the end of the day, several years ago, General Hyten, who was the commander of Strategic Command, had told us a secret about what is that thing that keeps our senior leaders up at night. And it wasn't China or Russia or Iran or even North Korea. What he talked to us about was that he fears as a nation that we've lost the ability to go fast and that our near-peer competitors are moving faster than us in hypersonics, in space, and taking commercial technology and fielding it faster than we are. So in that vein of trying to move faster, digital engineering is a critical piece to help us move at the speed of relevance. So I'm happy to have both Colonel Diller and Colonel Bartolome here. Colonel Diller, if you want to just give a few minutes of just your background, and Colonel Bartolome as well, and we'll get going. Colonel Diller.
Super. Thanks, Stuiki. Appreciate the opportunity to talk to this great audience. To talk a little bit about the things that we're doing with the AFWERX, and in particular about what really could be a significant revolution in the way we design and build in America and with our allies. I'm Nathan Diller, the director of AFWERX. Just over 6 months ago, we've done a pretty notable restructuring of AFWERX, taking an approach to scale the way we are bringing in new commercial technologies, looking at different partnerships across the innovation ecosystem, looking also to scale the partnerships internal, the entrepreneurs in the Department of Defense, in our Department of the Air Force, the Guardians and the Airmen who are doing these innovative activities and helping us scale this innovation. And then working in particular to drive those capabilities across what we in DoD call this Valley of Death through our prime programs. The first of those prime programs is Agility Prime, the Air Force Flying Car program. We can talk a bit more about some approaches that we're looking at with digital engineering in particular, with that electric vertical takeoff and landing technology, and ways that we might be able to accelerate both the commercial use as well as DoD utility. So excited to have the conversation. Appreciate you having me on, and really looking forward to it, Stoichi.
Yeah, absolutely appreciate it. Colonel Bartolome, just a little quick background.
Yes, it's great to be with you, Stoichi, and your entire audience. My name's Jason Bartolome. I'm the program director for the Ground-Based Strategic Deterrent. I'm leading the project to replace one third of our nuclear triad, the land-based leg of the triad. And for those that may be aware of the project or not, it's a mega project of epic proportion. We've got not only deploying a new nuclear capable missile, but we have over 600 construction projects, new missile system, command and control, cyber. So for the engineers in the room and the technologists, there's just something for everyone in this weapon system. And so many may not realize, but in the 50s and 60s, when we developed the system the first time, the entire discipline of systems engineering was born in this weapon system. And I've been a part of it for almost 7 years now, and I really feel like systems engineering 2.0 and digital engineering is being reborn in the development of the system. And so, Stoichi, super excited about the dialogue today. I think your partners there will be really interested to hear some of the things we're doing, both in the digital engineering domain, but how we're designing the system to be an innovation-friendly weapon system. And it's just amazing to work with great airmen like Colonel Diller and the AFWERX team on really just making us the most competitive and strong military as possible.
No, I appreciate it. Right, excited for both of you to be here. To frame what is digital engineering, because some people just don't have this context, right? That digital engineering really depends upon the creation of nearly perfect virtual or digital models and environments that harness the full power to learn and experiment, so that the actual physical systems are fully integrated and tested before production, right? To move faster, to save cost. And the Air Force, as I hear, kind of articulates three main key principles around achieving digital engineering goals, right? I hear own the tech stack, right? Warp the tech stack to the edge. And then create before you aviate. And so can you provide a little bit of color, some context, some atmospherics to understand that strategic approach? How is the Air Force thinking about digital engineering and how it needs to be structured so that we can scale, or open systems or modular, or how should we think about this? How should vendors think about this so that they can help us solve some of these national security strategies and help us move faster?
Yeah, so Stoichi, I think I really liked some of the thoughts that were in your question. I mean, one is that in GBSD, the way we've been thinking about this is really digitizing the product development cycle, or for those in the military applications, the systems engineering B, and really, from requirements generation to conceptual design to the detailed design to the actual fabrication. All the way through to production sustainment, we're looking at ways to digitize that entire process in ways that I think we need help. I think from industry in big and exciting ways. And you talk about sort of the tenets of digital engineering from the Air Force perspective. Owning the tech stack, warp to the edge, create before you aviate. And for GBSD, I think it's important for industry to understand how the Air Force is approaching this maybe even more strategically. And where I would start is we're designing, at least GBSD, and I see other large weapon system programs in similar light, is a flexible design or a flexible architecture that abides by modular open system standards. We have a lot of interest of owning the technical data and key interfaces. And what that does is it allows us to create an ecosystem around the weapon system in ways that in previous years and previous generations, we just really couldn't do because we were dependent on a single prime contractor for the life of the system. So in our world, we're exploring ways to actually open up the weapon system and for it to be a living and breathing system that can live and breathe with the innovations and the technologies of the day. The second piece for us is digital engineering. That's really the point of this conversation. And we can talk a little bit about the specifics that we've enjoyed in GBSD. The other one that we're really focused on in our world is DevSecOps and modern software development practices. Yeah. And what we're finding in GBSD is that there's this wonderful synergy and maybe some emergent properties that exist sort of at the nexus of a flexible architecture that can be modernized more easily, a digital engineering environment that really allows us to see the weapon system, and then our software development practices. And so talking about owning the tech stack, one thing that we've been working pretty closely with AFWorks is really developing not only a government furnished digital engineering environment that we've been sharing broadly in the Air Force and with the Space Force. So we have what we call the GBSD snow globe that sort of outlines the technologies that we're using to digitize the systems engineering V. But we're also working on a government furnished cloud environment that allows us to share not only within the government, but also with industry partners. In fact, today I had a wonderful demo at a multi-classified environment where I could trade and share information with industry and government elements in the cloud environment, which was fantastic. And the other thing we're working on with Platform One and the software pros is a government furnished software factory that we've already put in play and is really the basis for GBSD. So GBSD is owning the stack in all three of those dimensions. And when we talk about warp to the edge, we are working with the operational community, the intelligence community, and really technologists. And we see there's 2 or 3 key areas that we need to be able to design the system to address. One is what the adversary is doing clearly, which is really a red versus blue sort of problem. In the military, red are the bad guys and blue are the good guys. And so we talk about red v blue, but there's also this space that knows no good guy or bad guy, and that's technology. And what we really want to do is create innovation-friendly weapon systems that when you all develop capabilities in the market, we can more easily bring those on inside the system. The last thing is the create before you aviate, and I love that one a lot. So in GBSD, one of the things that was one of the tenets before we went and awarded the contract we awarded this last fall, which was a multi-billion-dollar contract, was we examined the trade space of designs on the government side, and we asked industry to do the same. And we examined over 6 billion different configurations of the GBSD weapon system against every requirement that we were interested in. And so we see a big place for modeling and simulation, big place for heuristic optimization, a big place for a lot of big data and analytics to really inform what we're doing. And I think that's a good summary of the path we're on in GBSD.
No, Colonel, I mean, that's awesome. And you talk about, vendors, being asked to bring ideas, right, to work with the commercial market, right, and varying technologies and processes related to digital engineering, things like virtual work environments, rapid prototyping and demonstration, big data management, analysis, visualization, virtual reality, digital thread, digital twin, and cybersecurity, and much more. So, Colonel Miller, how is AFWorks influencing, right, the adoption of digital engineering within the Air Force? And what are we learning from the commercial sector so far?
Yeah, thanks a lot. I mean, I'm going to start with the word that you used last there is learning. And I think what Colonel Bartolome just outlined, when you look at our Chief of Staff's mandate to accelerate change or lose, the core of that acceleration is speed to learning. And that's what this digital engineering, this is the reason I think it's so revolutionary, because it's not go build PowerPoint slides, have a briefing, have a series of action items, and then 3 months later you get the whole team back together. It's you dig in and you get answers right away, or you realize that, hey, we need to go back and the analysis isn't there. But the speed of learning is what's amazing, and that's where we hope we can accelerate that learning as well, where we're not just taking the learning that we're getting internal to DoD and building off the tool sets in DoD. And what we don't want to do is go and create hundreds of different tools, that we don't have a way of exchanging data between those tools. But we do want to keep the aperture open as we look to see, there's been the discussion of the Formula One race cars, and the learning that's happened there. When you start to have the conversations that we've had with many of the investors, a growing interest in this type of software that touches hardware, being a new competitive advantage for many companies in moving quickly and across the entire life cycle from design. It's very interesting, the things that happen certainly in manufacturing, in flight test, and then across that entire life cycle. When you look in operations and sustainment with the digital twin, being able to identify problems well before they become problems, so that you're creating this approach to sustainment that really, we've never had before. So what is AFWorks doing? We launched back in December this idea with our Dayton Digital Works. And we're starting really with a couple of small projects, 3 of them looking associated with our Agility Prime program. So the Agility Prime program, is the large electrical power system meets the components of your small drone for this idea of a flying car. And when we look at the many companies that are out there, some of the companies, startup companies, but some of them are very mature aerospace defense companies. Where are there areas in those that, one, we may not be using internally to DoD? So there's tools and processes that we might be able to bring in. 2, when we look at the speed that these vehicles are being developed, when we look at the speed that ideally future aerospace systems are being developed, we want to be able to bring those into service quickly. Our threshold to that is certification. And so there's some great lessons learned. I mean, I think it's one of the beautiful things really of how we leverage taxpayer investment in a program like GBSD that's working on things like nuclear security. How do we look at the types of model-based systems engineering that allow us to quickly go through a systematic approach to ensuring whatever flavor of safety or security for the system, for our electric vertical takeoff and landing, right? It would be an airworthiness. So modeling some of those approaches, seeing what's there available in the near term, and then finding ways that now in this new world where you've got, folks doing flight tests in their backyard. I mean, this is a very new world that we're in aerospace today. We have to make sure that bureaucracy stays up with that. And so with that approach to airworthiness, we hope to leverage some of the lessons from GBSD. There's other fantastic folks that are working across the Air Force Material Command that are engaged in that effort. And then the last piece is workforce. We have to have a 21st century workforce that knows how to use these tools. And so looking to see where we can slowly pilot those centers of learning so that we have a workforce that's ready to quickly take these tools, to take these new technologies and bring them into our government systems, initially internal to DoD for airworthiness, for things like nuclear surety, and then having these processes available then for the follow-on systems. So many of those things are happening in fantastic small companies that are on SBIRs through AFWorks today. We intend to investigate those through AFWorks, being able to harvest those from the smallest company out there to the largest prime. How do we create the best environment to learn as quickly as possible to make sure that we're bringing both prosperity through building these companies quickly and security to our nation through the very important programs like Jason's working on?
No, I appreciate it. And Colonel Bartolome, what are some of the successes that we've already seen in the Air Force, including your program? If you want to talk a little bit about what is your program, right? What is ground-based, GBSD, and what are you already seeing as some of those successes for digital engineering and some of those future challenges and maybe where this could go in the future?
Yeah, so great question, Stoichi, and I'm really struck by Nathan's comments about learning, and I think one of the things that we're finding in GBSD is that with modern information technology and the tools that are coming online and the standardization around ideas like SysML and the standards that you're starting to see that really help align the tools that allow us to engineer systems, what we're finding is that there's a democratization of knowledge, and really the knowledge is much more accessible to a broader audience. In the old days when I came through, you might have 500 engineers distributed very geospatially across the supply chain, and the knowledge about the system existed inside of binders that sat on people's desks, and then it kind of graduated into a SharePoint file, and Lord knows about SharePoint or Dropbox, but now you have these environments that are really amazing because they're searchable, and the knowledge that used to be only allowed to very few and select are now is available to the many. And there's a real great thing happening there. And I will tell you, early on in GBSD, there was a resistance because for some of our senior most people and the most talented people, it was a little scary because their competitive advantage inside of the project was that they were the most knowledgeable and the smartest. Yep. And now that C student that they were in class with, is as smart as they are about everything. Yep. And it's just not fair, So what we're finding is that what it's doing is it's taking, some of our students and our employees that used to be sort of here, and it's taking them there, and it's taking our best ones, and they're legendary in these environments. And so what I'm finding is that the most brilliant minds actually tend to love this because it allows them to create and allows them to move. The other thing I really see, Stoichi, particularly in a development as large as GBSD, is the statistics for mega projects are not very favorable in terms of them occurring on time or on schedule or meeting their technical performance. But this may not surprise you, but might surprise some, is that in 6.5 years, GBSD has actually hit every single milestone that we had set out. Every design review, every milestone A, milestone B, every single milestone for 6.5 years has been met on time. And we believe that what we're talking about is a big contributor to that. The last thing I'll hit on again, and I think this is along the learning piece, but I also think the innovation side for some of the companies out there is that, General Hyten actually came to visit us about a year ago, and he was concerned about speed and the concern about our adversaries being comfortable to fail. And what I shared with him and I showed him is that, sir, I fully expect to fail thousands and thousands, if not tens of thousands of times in my program. It's going to happen very quickly and fast up and down my supply chain. And that really resonated with him. And when we talk about airworthiness certification or nuke surety or cyber certification, I mean, one of the things that we're really concerned about in industry you can help are those long rework cycles that happen after you discover something went badly.
No,
And the thing that we're-
absolutely.
Yeah.
You put a really good thread, and bringing it back home with the 30 seconds that we have remaining in regards to understanding from General Hayden's perspective of that speed, of that need, right? And from your program, you hitting all those milestones and having that tremendous amount of impact, and how the Air Force could, potentially save billions and right, help our national security. And so for Colonel Diller, for those companies that want to work with you, right, same thing with the Defense Innovation Unit, right? People can go on and see solicitations at diu.mil. For yourself, Colonel Diller, how can companies participate with AFWorks?
Absolutely. AFWorks.af.mil. We're just closing out one of our solicitations. There'll be another one over the summer cycle.
No, fantastic. I appreciate you guys being here. Look forward to continuing the discussion with digital engineering and moving the Air Force forward. Thanks for being here.
Thanks a lot, Stoichi.
Thanks.